Hi, my name is Martin Phan, and I'm a field CTO here for North America at CalLogic Software. And in this demonstration, we're going to be talking about cross-account and cross-cluster restores of your Kubernetes applications using Cloud Casa. So as an example, let's say I have two Amazon EKS clusters. Cluster A, which I'm running on the East Coast, and Cluster B on the West Coast, and I manage them with separate accounts in AWS. Each cluster has access to its own unique storage classes on which it stores its persistent volume data. So if I'm protecting the contents of my application in cluster A, I want to be able to easily restore that data to cluster B while making customizations to the naming conventions or mapping to a new storage class available in my target cluster when restoring my persistent volumes. And I can do so very easily through Cloud Casa. With this in mind, let's go ahead and jump into the demonstration. Before we jump into Cloud Casa, let me show you around my environment. What I have here are two Kubernetes clusters that I'm managing with separate accounts on AWS, and you can see that I'm connected to each in a separate console window on my Windows desktop. My source cluster here being identified by the hot pink color and my target cluster being identified by the neon yellow cluster residing on the West Coast. And I have different storage classes defined to each of them. As you can see, two storage classes on my source cluster containing both a CSI storage class and an EBS storage class as well. And on my target, I just have the EBS storage class here that gets provisioned by default when I created my Amazon EKS cluster. So here in my source cluster, this is the cluster that I want to back up. The application that we're interested in today is my WordPress application, which resides in my test website namespace. And this has persistent volume data that's hosted on my CSI storage class. What I want to do is back up that data and from the East Coast and restore that data to the target cluster on the West Coast using a valid storage class defined to that cluster, which is in this case the EBS GP2 storage class. Jumping over to my Cloud Casa UI, the first thing I'll need to do is register both clusters into Cloud Casa. And I can do so by simply adding the Amazon account to my Cloud Casa configuration and creating the CloudFormation stack to tie the Cloud Casa server to my Amazon Web Services. Now we've changed the UI up a bit since the previous version, so to do this, just go into the Configuration tab and under Cloud Accounts, you'll click on Add Cloud Account. And from here, you can click on the Launch Stack button to bring up the CloudFormation console wizard. And from here, you can authenticate against your user. I think I already have a cache session token here. But what I just need to ensure down here is that my option parameters for this role, that role is able to manage EKS clusters, able to take EBS volume snapshots in, if applicable, able to manage RDS databases as well. So at the very bottom here, I can click on the Acknowledge checkbox and go ahead and create the stack. Now I already have my account scanned in, as you can see here, so I can run an inventory against this account and see all the RDS and EKS clusters that this account has access to. In terms of clusters, what I have here is a cluster already defined with the agent installed. You can see it here identified in my Cloud Casa account as Kubernetes source, and you can see that as active. If I want to install another cluster or an agent on another cluster, I can just simply click on the install button. Here I'll receive my kubectl apply command that I can use to pull down an agent and install on that cluster. Now once I installed the agents on the cluster, I should be able to see the active clusters available in my dashboard underneath the protection tab. So I now have both my Amazon EKS cluster scanned in, my source cluster, and my target cluster registered and configured to Cloud Casa. What I want to do now is back up the contents of my application namespace test website from the source cluster and restore that into my target cluster. So I'll select the source cluster here and click Define Backup. And from here I can give my backup job a name and the cluster that I want to back up from. In the next screen, I have the option to back up the entire cluster or select an individual namespace. In this case, I'm only interested in the contents of my test website application. Here you can also see I have the label selectors available as well, and I'll want to include the persistent volumes since that contains all the data to my databases and my web application. I also have the option of enabling pre and post backup functionality through application hooks. So I won't need to do that for now. This is the important section. So I'll have the choice between snapshot only and snapshot and copy. And this is where I'll need to select the snapshot and copy option to copy the cluster and its persistent volume data over to Cloud Casa or my own object storage. And I can define this in the preferences under the advanced options, but I'll go ahead and back this up to my Cloud Casa storage, which is also inherited from my cluster preferences. So on the next screen, I'll be able to schedule this job by defining a job schedule, as you can see here, or run it ad hoc, which I'll go ahead and do. So I'll go ahead and run this job and maintain it for a period of 7 days. So you can see here that I've successfully started the backup job, and if I jump back to my dashboard, I can see that backup job running and take a look at the activity log for that backup job. And there you see it's now completed. So now that my backup's completed, let's go ahead and define and run a restore job to my new target cluster. So to do this, I'll go ahead and click on the restore button in my dashboard, and I'll go ahead and select the latest recovery point that I copied over to my Cloud Casa server. Here I can choose which namespace I want to restore, in this case test website, and also enable application hooks if necessary. And I'll want to ensure that I include my persistent volume, so I'll make sure that exclude persistent volume is set to no. I'll give my restore job a name. And I also have the option of creating an EKS cluster directly on Amazon or using an existing EKS cluster. I'll go ahead and use the EKS target cluster that I scanned in previously. And from here, go ahead and rename the namespace, providing my initials as the prefix and today's date as the suffix. And because I don't have any CSI storage classes in my destination cluster here, I'll go ahead and map my original CSI storage class over to my EBS storage class on my target cluster. And click restore. I can see the restore job running, and we'll check the activity log here, and then we'll go back and check the cluster once the restore is complete. So as you can see, my restore job is now successful and completed. So I'll jump back into my target cluster here and take a look at the resources that are available on it. So you can see that I have my application restored in a namespace that I customized with my initials as the prefix and the date as a suffix here. And we can take a look at the available persistent volumes. And you can see that I have new persistent volume claims from my application going to the EBS storage class on my target cluster. So there you have it, cross-cluster and cross-account restores using Cloud Casa. This can be easily done by just simply registering your Amazon accounts and defining a backup and restore within the Cloud Casa Management Console. So hoping this provide you with some ideas as how you can structure your data protection and disaster recovery strategies for your cloud-native applications. If you do have any questions, please feel free to visit our website at cloudcasa.io. You can even contact me directly using the contact information in the links provided below. Thank you and have a great day.